Kesungguhan Akademi Youtuber Malaysia Rangka laksana dengan jitu penuh bervisi Guru AYU mencapai misi yang satu bervisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum, salam sejahtera, selamat malam dan selamat datang ke kelas tuisyen online percuma yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia, Kelab Guru Malaysia dan e-didik Malaysia bermula percuma selamanya percuma. Untuk memulakan kelas kita pada malam ini, ayuh kita mulakan dengan Al-Fatihah dan doa belajar. Yang bukan Muslim, anda boleh bertafakur mengikut bacaan masing-masing. Al-Fatihah. Amin, amin, ya rabbal alamin berislam. Sekali lagi, Assalamualaikum dan selamat datang kepada semua guru-guru, anak-anak murid yang cikgu kasihi dari mana jua anda berada. Saya doakan anda sentiasa sihat walafiat. Dan Cikgu Hasnitah mengambil kesempatan untuk mengucapkan selamat Hari Kebangsaan yang ke-68 hari ini 31 Ogos 2025. Malaysia Madani, rakyat disantuni. Okey, jadi sebelum cikgu bermula, pada bahagian pin message cikgu ada letakkan pautan kepada PDF kopi. Anda bolehlah klik nanti dan muat turun dan cetak keluar secara percuma. Anda boleh gunakan sepanjang anda mengikuti kelas pada malam ini. Alright? Kalau tak sempat print, tak mengapa, tengok dulu kelas ini, kemudian anda boleh print dan tonton semula video ini untuk mendapatkan jawapan yang penuh. Jadi siapa yang ada bersama kita pada malam ini, anda boleh say hi pada live chat yang baru pertama kali mengikuti kelas Cikgu Hasnitah. Terima kasih dan boleh share lagi link kelas ini kepada rakan-rakan yang lain. Okay, so untuk malam ini, for tonight, for this evening, I will continue on the 6 content standard on chapter 5, which is 5.6 interference of wave. And students, this class will be conducted in English or for DLP students. Tapi belajar bukan DLP pun boleh sertai, tak ada masalah. Alright. Okey, jadi kalau anda sudah bersedia, mari kita bermula. Okay, if you are good to go, let us begin. But before that, let me introduce to you the physics panel we have in Akademi Youtuber. Cikgu-cikgu inilah yang telah banyak membantu saya untuk menjadi presenter kelas, membuat perkongsian kelas tuisyen percuma secara langsung. Mereka juga banyak menerbitkan video-video PDPC untuk fizik, sama ada dalam bahasa Melayu maupun bahasa Inggeris untuk kelas DLP. Kepada yang belum lagi muat turun apps Akademi Youtuber, anda boleh muat turun apps ini di Android anda. Apa yang ada dalam apps ini, kita ada puluhan ribu video PDPC yang dihasilkan oleh sukarelawan Akademi Youtuber, bermula dari peringkat pra sekolah hinggalah ke pra universiti. Jadi semoga video-video yang dihasilkan ini membantu anda membuat ulang kaji dan memahami topik-topik tersebut dengan lebih baik. Okay students, so let us begin our discussion tonight with interference. Again, you can click on the link for the PDF copy for this lesson. And for students copy, there are a few blank spaces you need to work on, especially on the exercise or the practices part at the back. Okay, dan kepada yang biasa mengikuti, kita akan kongsikan pautan kepada e-sijil express di hujung kelas ini. Nanti anda boleh isi nama dan nombor kad pengenalan dan sijil akan dihantar ke email yang anda gunakan. Okay, so without further ado, let us begin with the first learning standard. It is to explain the principle of superposition of a wave. Okay, so you may sit in the most comfortable way and be ready with your textbook or your calculator, so on as well. Okay, let us begin with this situation, students. Can you tell me what can you see on the screen now? Observe the situation. What did you see? Yes, okay, so this is what we are going to discuss tonight. And again, for the second situation, when two stones drop into water simultaneously, what would you see? As in the picture. Yes, very good. So you can see two circular waves produced and are in superposition. Okay, as in the first GIF before, you see they are circular wave produced and they are overlap to one and another. So we call this as superposition of wave. Okay, so what is superposition? So in this lesson, principle of superposition of wave is when two wave overlap. Okay, and the resultant displacement will be the sum of the individual displacement of the wave. For example, in this picture, there is a two wave coming from opposite direction, the blue arrow and the red arrow representing the first wave with amplitude A1 and the second wave from the right side representing by amplitude A2. So when they are overlapped, so you will see the amplitude will be A3. A3 is the sum of A1 and A2. So again, what is principle of superposition? It is a situation when two waves overlap. So the resultant displacement is the sum of the individual displacement of the wave. Okay. So can you hear me clearly? If you do, can you type 1 in the live chat? Thank you. Okay, so again, this is another situation. So when two waves meet, students, so this is before the two waves are meeting. So then when they meet, they will overlap. So we say they are superposed. Okay, thank you very much for your response, Mr. Madan Mohan. Okay, and continue to move in the original direction. Okay, so this is before, during superposition, and after superposition, the two waves continue moving in the initial direction as shown in this GIF here as well. All right. Okay, and then, okay, so the first terms for you to understand is superposition. Okay, so what is superposition? It is a situation where two waves overlap and then the resultant displacement will be the sum of the two wave. Okay, the sum of the amplitude of the two wave. Yes, very good. Okay, now we go to interference, the second terms. Okay, so if you look at this diagram, okay, so just now we understand superposition. And student, if you notice, for superposition to occur, the two or more wave must be come from a coherent sources. So what is coherent sources? So coherent sources refers to the source that produced the wave must have same frequency or same wavelength and they are in phase. Okay, for example, if you look at this GIF, there is a double slit there which represent our coherent sources. So number one, okay, the wave produced from these two slits have a same frequency. For example, if on the left side has the frequency of 10 hertz, the other side also having a frequency of 10 hertz. And they have a same wavelength and in phase, which means if the first source producing crest, the second source also producing crest at the same time. So if you look at the diagram up here, this is example of two sources producing light wave. On top is an incoherent light. Okay, so you can see they have different frequency and different phase as well. And down here, this is example of coherent sources producing the light wave. So first one, you see they have the same wavelength, same frequency, and they are also in same phase. Okay, or we say they are in phase, producing crest and trough at the same time. Okay, so what is coherent sources? It is the sources producing wave with same frequency and in phase. Alright? Okay, so that is the second term. Okay, then when we talk about interference, there are two types of interference, students. The first one is called as constructive interference. So what is constructive interference? It is an interference when two crests or two troughs are in superposition and produce maximum resultant displacement. So there are a few keywords there. So for you to understand first, the two wave which is overlapping must be involving crest. Both are crest or both are trough, and they are producing maximum resultant displacement as shown here. Okay, constructive interference. On the blue arrow, it shows the wave, the first wave coming from the left side, and the red arrow shows the second wave coming from the right side with amplitude A for both. So when constructive interference wave, which means these two crests are superposed, so you will see they will produce maximum resultant displacement where the amplitude is 2A or double A. Okay, and down here we have also constructive interference involving two trough. Okay, the first trough with the magnitude minus A showing the downward position, and the second trough also with amplitude negative A. So when they are superposed, see, they will produce maximum resultant displacement with negative 2A. So are you clear with constructive interference? If you do, you can type number 2 in the live chat. Okay, so as a Malaysian, we just received a very good news today in conjunction with our Merdeka Day. Our mixed double in badminton just crowned as a world champion. Yeah, congratulations to To Iwei and Chen Tangji. And for your information, I am a fan of sports, especially in badminton. Okay, so second, okay, we go to destructive interference. Okay, again, thank you for your response, Mr. Malenwa. I guess you are a teacher, do you? Okay, destructive interference. Okay, a crest. Okay, destructive interference refers to the superposition of a crest and a trough. Okay, so they will produce zero resultant displacement, okay, as shown in this diagram. So the first wave is a crest moving to the right, and the second wave we have a trough moving to the left. So when they meet, what happened to the amplitude? So the amplitude will be cancelled off, producing zero resultant displacement. Okay, so this is example of destructive interference also show in this GIF. All right, okay. So that is the first learning standard done. We have discussed the first one is superposition, and then second interference. Then we have two types of interference, namely constructive interference and destructive interference. Okay, so now let us move to the second learning standard to describe the pattern of interference for water, sound, and light wave. All right. Okay, so in your school, in your physics laboratory, I believe you have this ripple tank. This ripple tank is used to study not only interference of wave, but also reflection, refraction, and diffraction of water wave. So if you look at this diagram, so this is our two coherent sources, two circular dipper producing circular wave. So when the wave are overlapping, you can see constructive and destructive interference are produced. All right, okay. So this is the pattern you can see, student. And here we are going to meet with the next term, antinode, antinodal line, node, and nodal line. So what are those? So what is antinode, student? If you look at this diagram, you can also have them in your textbook. So this is the first source producing wave, and this is the second source producing wave. Before that, please be alert with all this thick and thin line. So the thick or bold line represent the crest of the water wave, while the trough, the thin line represent the trough of the water wave. Okay, so there are a few red point mark on the intersecting between these two waves. Okay, so first, what is antinode, student? Antinode is a point where constructive interference occur, which means it is a point where a crest of the first wave meet with the crest of the second wave, or it is a point where the trough of the first wave is meeting with the trough of the second wave. Okay, so for example, this point, this point which I pointed just now, this is a point where a crest of the first source meet with the crest of the second source. And the thin line here, this is a point where the trough of the first wave is in meeting with the trough of the second wave. So it is also called as antinode point. Okay, and if you join all these points together as shown in the second diagram down here, so this line will be called as antinodal line. All right, so what is antinodal line? It is a line which connects all the antinodes. All right. Okay. And second is node. So this one is marked with blue point there. So what is node, student? It is a point where destructive interference occur, which means it is a point where the crest of the first wave is superposed with the trough of the second wave, or vice versa. The trough of the first wave is superposed with the crest of the second wave. So again, node is a point where destructive interference occurs. So a thick line is meet with the thin line. Mean it is a point where crest meet with the trough. Simple. And again, when you join all these node point together, we will construct a nodal line. Okay, Nodal. So what is nodal line? It is a line which connect all nodes. Okay, so our terms here, antinode, a point of constructive interference, node, a point of destructive interference, antinodal line, a line which connect all antinode points, and nodal line, a line which join all the node points. All right, okay. And this one is the study, this setup is to study the interference pattern for sound wave. So to produce interference of water wave, we need two dipper to produce the coherent sources. So here we are, yes, we require two loudspeaker, two identical loudspeaker, which means they produce a sound with same frequency and in phase, mean producing compression and rarefaction region at the same time. All right, okay. And this is how interference of sound wave occur. It explained in this diagram. So this is our first loudspeaker act as our first sources, produce the wave. The second loudspeaker as the second, and they are two coherent sources, producing sound wave with same frequency, same wavelength, and in phase. Okay, so you can see this is the point mark on where we place the microphone at. The microphone is moved along this line connected to the audio generator, and when we did this, you will hear an alternative loud and soft sound. Okay, for example, in this diagram, the yellow point, all right, the yellow point represent the anti-node point. Okay, antinode mean where constructive interference occur, so you will hear a loud sound on the yellow dot. Okay, here. Okay, so this is all the antinode point. Okay, the yellow line represent all the antinodal line. Okay, so this is a point where we will hear loud sound. And the cross point, the red cross point represent the soft sound. Soft sound is mean where destructive interference of sound wave occur. So this is a point where the compression meet with the rarefaction region. All right. Okay, this one where the compression meet with the compression or the rarefaction meet with the rarefaction the first and the second wave. So as I mentioned, when we move the microphone along this line, so we will hear a loud sound and soft sound alternately due to constructive and destructive interference occur. Okay, so I hope you are clear with this interference of sound wave. If you do, please give me number 3 there in the live chat. Okay, thank you. Okay, then we go to the interference of light wave, student. Okay, interference of light wave. Okay, to study interference of light wave, this is the setup required. Okay, again, thank you for the third response, Mr. Madan Mohan. Okay, so for interference of light wave, student, we don't need two light sources. Okay, all we need is a single light sources, but with double slit. Okay, so the double slit here. Remember, for single slit is used to study diffraction of light wave. So to study interference of light wave, we require a double slit. In your textbook, it is called as Young double slit experiment. Alright, okay. So this is our single light. We call it as a monochromatic light. Okay, what is monochromatic light, student? Monochromatic light is a light which produce light of a same wavelength, same frequency and in phase, similar to the definition of coherent sources. Okay, which means here we can use any colors of light and they will give you a different interference patterns on the light screen depend on what color of lights we are using, because each light have their own wavelength. Okay, and this is the double slit. So when the light pass through this double slit, as if we are producing two lights, so they will interfere and the effect of interference will be appear on this white screen. So you can see the width of the interference pattern will be different if you are using different sources of light. Red will have the biggest distance because red has a longest wavelength compared to other light, example green, purple, yellow, blue, and so on. All right. Okay, so this is the diagram shows to you the results of the interference of a light wave. So this is our monochromatic light. So when we propagate the light through this double slit, so interference of light occur. So we call this as the first sources. The first slit acting as our first source. The second slit act as our second source producing light. And you will see an alternative bright and dark fringes on the white screen. So what is the bright fringes represent? This is where, yes, constructive interference occur. Okay, this is the red line shows the anti-nodal line, while the dotted line here represent the nodal line. So constructive interference produce bright fringes, while destructive interference produce dark fringes on the screen. So if you see from front side, so you will see an alternative bright and dark fringes on the screen, which is brighter at the center. All right, okay. So that is an example of how we produce interference pattern for water wave, sound wave, and a light wave by using two coherent sources or monochromatic light. Okay, so what is two coherent sources or monochromatic light? It is a sources which produce a wave of same frequency, same wavelength, and in phase. Okay, so now let us move to our third learning standard. This is how to relate lambda wavelength A, X, and D for interference pattern of wave. So if you notice, when we study reflection, refraction, diffraction of wave, there is no physics formula involved there. But for interference of wave, there is one formula for you to understand, and we will use this formula to solve a problem involving interference of wave later in the fourth learning standard. Okay, so to understand what is all these parameter lambda, A, X, and D, let us take a look at this diagram, student. So you are given an interference pattern of water wave here. This is interference pattern of light wave over there on top, and also interference pattern of sound wave, which we discussed before. And here, there is a few symbol we can mark. Okay, first, this is the first source. The second source produced the coherent wave. So the distance between these two coherent sources, we label it with A. Okay, small a. So A represent the distance between the two coherent sources. So this is A for interference of water. This is A for interference of light wave. And the distance between the two loudspeaker is A. Okay, for light wave, it is the distance between the two slits. All right. Okay. And what about X? Okay, what is X? This is X. If you see, X is a distance between two consecutive antinodal line, or it is a distance between two consecutive nodal line. Okay, as mentioned here, X. And then for interference of light wave, X is a distance between two consecutive bright fringes, or it is a distance between two consecutive dark fringes. And for interference of sound wave, X is a distance between two consecutive loud sound, okay, or a distance between two consecutive soft sound. Okay, so I hope you're clear with A and X. Now let's move to D. So what is D, student? D is a distance between the two coherent sources and a point where X is measured. For example, we measure X at this point. So the blue arrow shows to you the distance between the two coherent sources and point X. Okay. And for interference of light wave, D is the distance between the two slit and the white screen, okay, where the bright and dark fringes are produced on. And for interference of sound wave, D is a distance between the two loudspeaker and where we place the microphone at. Okay, and finally lambda. Lambda, I believe everyone know lambda. Lambda is the wavelength. So how to measure lambda? Lambda is a distance between two wave front. Okay, for example, show with green arrow here. Similar for light wave and sound wave. All right. Okay, good. So the relationship between all these four parameter, lambda equal to AX over D. Okay, lambda equal to AX divide with D. Okay. So this one again shows to you all the symbol A, this is D, this is X, and the wavelength as well. So wavelength you can mark on the screen. This is the wavelength. Okay, we mark with lambda. Okay. Okay, good. Okay, next. Okay, let us take a look at this, how to understand the relationship between all these parameter. Okay, if you look at these two example, okay, can you observe and tell me what is the difference between these two diagram A and B? Okay, so first you can see the distance between the two coherent sources. Definitely, obviously you can see for diagram A, the two coherent sources are further away from one and another. Okay, in diagram B, they are closer to one and another. So the distance between these two loudspeaker will affect X, the distance between two antinodal lines, student. Okay, and here, what is one similarity? You can see they have the same distance of d. Okay, this is one similarity. They have the same distance of d. And here we maintain the wavelength. So our CV is wavelength and the distance between the two coherent sources and a point where x is measured, which is d. So our MV, the factor that we change here is the distance between the two coherent sources, so A. And our responding variable or the factor that being observed is x here. Okay, the distance between the two consecutive antinodal or nodal line. So here, from this example A and B, we can write A is inversely proportional to X. Okay, when A increases, so you can see X is decreases and vice versa. Okay, so student, this is again, now we compare B and C. So now here we keep constant the distance between the two loudspeaker, but we adjust the wavelength of the where to see the wavelength as you can see. For B, the wavelength is shorter. Okay, this is the wavelength. And for C, you can see the wavelength is longer. All right. Okay, so and then you will see it will affect again X. Okay, so here when we maintain A and D and we change the wavelength, so you will see the X also will be changes. So here we relate the wavelength and X, so it is obviously that the wavelength or lambda is directly proportional to X. So you can see when lambda increases, the distance between X also increase, or the distance between the two consecutive antinodal line also increases. All right. Okay. Okay, this is example of interference pattern for light wave. So this is our manipulated variable, the distance between the two slits. So you can see when it become wider, the distance between the two fringes are shorter. All right. The first example, we change the distance between the slit and we maintain the wavelength by using same color of light, which is red as shown in this example. So you can see when wavelength is keep constant and when the A is increases, so X decreases. Okay. And in the second example here, now we maintain the distance between slit. We keep constant the distance between the two slit, mean A is keep constant, but we are changing the wavelength by changing the color of light. And if you remember the position of the 7 spectrum of color in white light, which is red has the longest wavelength while violet has the shortest wavelength. So you can see when the wavelength is decreases, okay, so you can see the distance between the fringes also changes, okay, which is decreases. So, okay, then student. So that is the first 3 learning standards. So what if we take a short break for a while before we take a look at some example of exercise collection paper which apply the equation we discussed just now where lambda equal to ax over d. So don't go away. I will be back after this short commercial break. Okey, kembali lagi bersama saya Cikgu Hasnitah dari SMK Baganjaya Butterworth Pulau Pinang untuk kelas tuition online percuma Fizik SPM Tingkatan 4 dengan tajuknya 5.6 Interference of Wave. So welcome back to our lesson, students. So just now we have finished discuss the first 3 content standard. And now let us move to the fourth learning standard on how to solve problem involving interference of wave. Kepada yang baru saja mengikuti siaran ini, selamat datang kami ucapkan dan terima kasih kerana menyokong Akademi Youtuber. Alright. So let us try the first exercises on objective question. You may respond. You can share your answer in a live chat as well. Sebelum itu kita ada Norman di sana. Hai, selamat datang. Norman, adakah anda seorang guru ataupun pelajar? Mungkin boleh kenalkan diri. Okay, so in this question we have a young double slit. So whenever you see young double slit, so you understand this is referred to interference of light wave. So young double slit experiment, red fringes are formed on the screen when a red light source is used. So the question is, what will be observed if the light red source is replaced by a blue light source, student? So if you understand, when changing the color of the light sources, actually we are changing the, yes, very good, we are changing the wavelength of the color sources. And now, just now from the example I show you, X is directly proportional to lambda, which means when lambda increases, X also increases, and vice versa. When lambda decreases, so X also decreases. So you must know between red and light blue, who has a longer wavelength? Yeah, definitely red has the longer wave, which means here our wavelength is decreases from red to blue. So you understand X must be decreases. So what is X? Yes, X is a distance between fringes. So obviously the answer is donkey, D. Okay, distance between fringes decreases. Okay, second question. Okay, this one you have to calculate. It's a simple mathematics. You may take out your calculator as well. So this is the formula we are applying, lambda equal AX over D. So this diagram shows to you the setup for Young's double slit experiment. Again, interference of light wave. So the wavelength of the monochromatic light is given 6.5 times 10 negative 7 meter. Okay, you may highlight this important information given in the question. So the distance between the two slits. So what is distance between two slits? It is A. Yes, very good. 0.5 times 10 negative 3 meter. And the distance between double slit and the screen is 3 meter. So this represent D. Yes, very good. So we are given wavelength, lambda, we are given A, and we are given with D, so we can find X easily, distance between two bright fringes. Remember, bright fringes is where constructive interference occur for light. Alright, so how to solve this? Okay, so this is the solution. So you can you can rearrange this formula, making X as the subject as since we are looking for X. So it become this way, okay, from the initial equation. So we make X as a subject, so it become X equal to lambda multiply D divide A. Okay, so this is the substitution, the substitute in the correct home. So the wavelength is 6.5 times 10 negative 7 given in the question, and this is the distance between double slit and the screen, 3 meter, and the distance between the two slit, 0.5 times 3 10 negative 3 meter. So here we don't have much problem since they are all given in the same unit. If they don't, so you must put them in the same unit first. Alright, so the answer is 3.9 times 10 negative 3 meter, which is A. So this is a very direct question, how to apply this equation, lambda equal to AX divide with D. Alright, okay, now a structure question. Okay, let us try this. Okay, diagram shows a two loudspeaker. Okay, you see two loudspeakers. So we understand these two loudspeakers act as a two coherent sources producing interference of sound wave. Alright. Okay, so two loudspeaker connect to an audio frequency generator. Students are standing at position where loud sound can be heard. So the student is standing at the anti-nodal line where constructive interference occur, and as the effect they all will hear loud sound at the point where they are standing at. Okay. So if you notice in a hole, the position of the chair, it's not simply placed there. They actually place the chair in a point where constructive interference occur. So the audience can hear a loudspeaker from where they sit at. Alright. Okay, first, what type of wave is sound wave? Okay, physics student, what type of wave sound wave is? Okay, so actually you can write more than one answer here. First, we know sound wave is a longitudinal wave. Yes, it is also a progressive wave which propagate with time. And it is also a mechanical wave, which means it require medium to propagate. So it can be longitudinal wave, you can put progressive wave, it also be mechanical wave, but my priority is to write longitudinal wave. All right, okay. Okay, then second question B, why are loud sound heard by the student at that position? If you notice, I mentioned it readily. Okay, what happened at this position? Why they are able to hear loud sound? Yes, very good, because this is the position where constructive interference occur, or they are standing at the antinode, or they are standing at the antinodal line where constructive interference occur. Okay, great. Okay, now C, again we have to calculate. Okay, you are given the distance between the two loudspeaker, 1.5. So what is this? This is A. Yes, very good. And at 10 meter from the loudspeaker, okay, so this is D. Alright, distance between two adjacent row of student is 4 meter. Okay, distance between two adjacent row give you X. Okay, distance between two adjacent antinodal line. Okay, so you have to find the wavelength. So we are given with A, this is D, and this is X. Again, they are all in unit meter, so it makes our work easier. So find the wavelength. So you can jot down or select first the information, extract out the information given for A, D, and X. So we are looking for lambda. So how to relate this for? Very good, through this equation. Lambda equal AX over D. So we do the substitution. A is 1.5, X is 4, and D is 10. Okay, make sure you place them in a correct ohm. And our lambda, the wavelength is 0.6 meter. Easy, right? So if you're going to give mark, where is this 2 mark awarded at? First on the substitution, second mark in the correct answer with unit. Okay, remember in physics, all calculation must come together with a correct unit unless there is no unit provided. Either they are ratio or no unit available. Okay, good. Okay, next. Okay, D. Now we increase the frequency of the sound wave, student. We increase the frequency. So what happened to the distance between two adjacent row where loud sound heard? Okay, remember, we increase the frequency. In the equation, did you see any frequency there? No, right? But we understand frequency is inversely proportional to wavelength. So what happened actually when you increase the frequency, so the wavelength will be decreases, which means wavelength is shorter. So what happened to a distance between two adjacent? What happened to X when lambda is shorter? Remember the relationship between lambda and X just now, they are directly proportional, right? So which means when lambda decreases, X also decreases. Okay, give a reason for your answer. So how to give reason? Okay, so either you say because the wavelength decreases, or you can say x decreases when lambda decreases, or it is x directly proportional to lambda. Okay, good. But in your answer, you can write the full sentence. Okay, wavelength decreases, or you can say distance between two adjacent. Okay, write the full terms. Okay, x distance between two adjacent row decreases when the wavelength decreases. And then here x, you say distance between two adjacent row directly proportional to the wavelength. Okay, unless they represent all this quantity with this symbol in the question, then you can use them, all right, in your answer. Okay, now we go to the next question. This is also SPM past year paper, long year ago. Two diagrams, 6.1 and 6.2, show experiment on a sound wave. So whenever you see two loudspeakers, so we understand this is an experiment on interference of sound wave. Yes, very good. Okay, and they mark a few there. A, distance between the two loudspeaker. This is also in diagram 6.2, and there is x there. Okay, for 6.1, and this is 6.2. Okay, the black dot is a point where loud sound is produced, and the hollow dot is where soft sound is produced. Okay, first observe these two diagrams. Compare the distance x. Okay, you can compare x, which one longer, which one greater, which one smaller, and then compare the distance between the two consecutive loud sound in these two situations. You compare x in diagram 6.1 and 6.2. So obviously from this diagram, we can see x in 6.1 is greater than that in 6.2. So you write 6.1 greater in 6.2. Okay, this is to answer in structure question only. In essay, you must write the parameter. Okay, in essay, you must write distance between two consecutive loud sound in 6.1 is greater than that in 6.2. You can use this symbol, no problem, but you must it must come together with the parameter which we are comparing. That is how we answering this kind of question in the essay part, mean in question number 9, question number 10, question number 11. Okay. Okay, then compare the distance now, student. Okay, compare the distance between the two loudspeakers. So you can see obviously in 6.2 the distance is further. So we say 6.1 less than 6.2 or vice versa. You can mention 6.2 greater than 6.1. Okay, again in structure you can write this way, but in essay you must write the full sentence. You must write what parameter we are comparing. So you must write in full. Distance between two loudspeaker in 6.1 is less than that in 6.2. Okay. Okay, same state relationship between A and X. So yes, they are inversely proportional. Or you can say when A increases, so X decreases. Okay. So we can say inversely proportional since they are formula relating them. If there is no formula relating, you just can say A increases, X decreases. But since we have lambda equal to AX over D, where A inversely proportional to X, so we can write this A inversely proportional to X. Okay, state one other physical quantity that need to be fixed to ensure the relationship in A3 is correct. Okay, what you need to fix? Yes, you need to fix the wavelength, or you need to fix the distance between the loudspeaker to the point where X is measured. Okay, either one. And what is the physics phenomenon involved here? As I mentioned, when you see two loudspeaker producing soft and loud sound alternately, so we understand the phenomenon must be, yes, interference of sound wave. Or enough to say, interference. Okay. Okay, so are you doing good so far, student, with all this question? If you do, please type number 4 in the live chat. Thank you. Okay, now let us go to the next question. Again, question 6, comparison between two diagrams, 6.1. Now we have three diagrams, 6.1, 6.2, and 6.3. For those who are just joining us, again, I would like to I would like to remind you, there is a link provided in the video description below. Also, I have pinned it in the live chat so you can click on them, download for your digital module or student copy, and later you can print them out to use it together with this video whenever you are free. All right, as in revision for interference later in the future. Okay, what is meant by monochromatic light? Here we have a setup which is to study interference of light wave. All right. Okay. So here we are using a white light and we place a color filter here. If you see on the white screen, we are producing two color, red fringes and blue fringes, which mean the first experiment in 6.2 we are using red color filter. Okay, in the second experiment 6.3, so we are using blue color filter. All right, so first, what is meant by monochromatic light, student? Okay, what is monochromatic light? Okay, mono means one, single. Okay, so it is a light with one frequency, or you can say a light with one frequency and in phase. Okay, light with one frequency, one wavelength, and in phase. Okay, or you can say light with same frequency and in phase. All right. Okay. Next. Okay, using the pattern of the fringes for red and blue, state to observation about the distance between consecutive fringes for the red and blue light. Okay, how we compare? So first we can say the distance between the two consecutive fringes for red light is greater than blue light. Okay, so where to see this distance? Okay, this one. Okay, from here to here, okay, this is X. Okay, and for blue, from here to here, this is X. So you can see X for red is greater compared to blue light. Okay, second, what can we say? If you notice, the distance between the two fringes for both red and blue, they are constant. They are the same. Distance between two consecutive fringes for the same light is equal. Okay, so here, if X is 3, so for the second and third also 3 cm. The third and fourth also 3 cm and onwards. Same goes to blue. If the first fringe and second fringe distance 1 cm, so the second and third also 1 cm, then 9 and 10 also 1 cm. All right? Okay. Okay, now in C, compare the wavelength for for red light to blue light. Okay, so you see just now, we understand red light has a longer wavelength. So how to compare? Wavelength of red light is longer than that of blue light, or vice versa. You can say a wavelength for blue light is shorter than that in red light. Teacher, what is relationship between D and X? Okay, D and X you can check from the formula, Joris. Okay, you can check from the formula D and X. Okay, lambda equal to X. So you place them in the different side. Then only you can see. Okay, for example, let us write the formula here. Lambda equal A X over D. So now X and D on the same side, right? So you can see the relationship. So in order to see the relationship, you must move D to the other side. So I write here, yeah. Okay, so we have lambda D equal A X. Okay, or you want to see more clearly, we just leave D alone here. So D equal A X divide lambda. So if you look D and X, what are their relationship? So both are on top, right? Yes, it is directly proportional. Clever. Okay. Okay, thank you, Joris, for your question. Okay, next, let us check for D. Okay, relate wavelength of red light to blue light with the distance between consecutive fringes. Okay, how we relate this? Relate lambda to x, student. So you can see just now from the equation, we understand A and lambda is directly proportional. So you can say when wavelength increases, distance between consecutive fringes increases. Or you can say directly proportional. Okay. Wavelength of the red light to blue light is directly proportional to the distance between consecutive fringes. Okay, and then name the wave phenomenon. Again, asking for phenomenon. This is very easy. So it is interference of light wave. So enough to say interference. Okay? Yes. Okay, now our final question. Okay, final question for this evening. 10 mark essay question. Okay, they give us this table 4. It shows 3 classroom in your school are combined to become a lecture hall. Alright. Table 4 show 4 type of sound system to be used in a hall. So we have P, Q, R, and T. And then they give us 4 characteristics. The whole flooring, P and R made from cement, while Q and T is covered with carpet. And then the distance between the two loudspeaker is small for P and T, and the distance is great or large for Q and R. Okay, so this one distance between two loudspeaker, it is represent A. Okay, we understand this represent A. And then third characteristic, the material used to cover the wall. Okay, so for P and Q, they are covered with thick curtain, and R and T covered with hardwood. Okay, one we have thick curtain, another option we have hardwood. And for the position of the microphone, okay, where to place the microphone? Is it behind the speaker or in front of the speaker? Okay, the microphone, where to place? In front of the speaker or behind the speaker? Okay, so let us see. So your justification is to design the sound system which produce better quality of sound. Okay, so let us take a look at the recommended answer. Again, you are highly recommended to place your answer in a form of table. Okay, the first characteristic. Okay, write back the whole flooring. Okay, carpet or cement. So definitely carpet. Why choose carpet? Because it absorbs sound or it causes less disruption. Okay, and then second characteristic, the distance between two loudspeaker. A. Okay, better to be large so that we will have distance between anternodal line will be decreases. Okay, remember just now A inversely proportional to X. So it will produce smaller distance between the two loud sound, which means more point producing loud sound will be produced. Okay, and then the third characteristic, we choose thick curtain instead of hardwood for the wall. Why? Because thick curtain can absorb sound. This is to prevent echo. Okay, if you notice, in a concert hall, normally the wall is made from cushion, a soft material. So this is to absorb sound and to prevent echo, reflection of sound wave. Okay, then the position behind the microphone. So where to place the microphone, student? So the best place is to place the microphone behind the speaker. Okay, why behind the speaker? So this is to avoid noise due to the sound from the speaker pick up by the microphone. If you put it in front of the speaker, it will catch the sound. So it will be a disturbance. Okay, so which is the better choice? So we choose Q. Okay, we choose Q for all these reasons because the whole flooring is covered. It has large distance between two loudspeaker. Material used to cover the wall is thick curtain. And finally, the microphone is placed behind the speaker. Okay, so remember you can use the tick to pick method to answer this. So you tick first all characteristic, and finally you pick which fulfill the most characteristic. So it is Q for this question. Okay, next, the last part. Okay, so let us see where we could see application of interference in our daily life. Okay, first you can see it in this bulbous bow. Okay, the front part in a hull of a ship. So bulbous bow generate water wave which interfere destructively with the water wave around the hull. Okay, so this will cause the water around the ship to become calmer and thus reduce water friction or water drag. So I show you the animation here. Okay, sorry, it could animate. This is a stiff diagram. Okay. But you can find from the internet bulbous bow GIF. All right. Okay, so this is the first diagram. It shows a ship without bulbous bow. Okay, students, so you can see this is the sea wave. So since the sea wave is not cancelled by the bulbous bow, so the ship will move up and down. Okay, so this is dangerous and somehow it can cause the sink to be unstable, and there is a risk for them to sink, especially when they are overloaded with cargoes. Okay, and down here is a diagram shows a bulbous bow. So you see this structure is a bulbous bow. So the blue line show the water wave. Okay, and the red line shows to you the wave producing the wave which is interfere destructively producing by the bulbous, so it will cause the displacement to be zero, so where the ship is calmer. All right, okay, good. Okay, so again the purpose of the bulbous bow is to generate water wave which interfere destructively with the water wave around the hull, so the ship can cruise in a calmer situation. Okay, second is in an anti-reflection lens. So if you are wearing glasses, students, so you can check either your glasses have this anti-reflection lens or not. Okay, so this is the two example without and with. Okay, this is without anti-reflection. This is glasses with anti-reflection. Okay, so coating on the surface of the anti-reflection lens causes reflected light to interfere destructively as shown in this diagram. So what is the purpose? This is to help to improve vision and to prevent formation of image on lenses which can distract our sight. Okay, any example contoh. Okay, so you can see this is the diagram, a lens without anti-reflecting coating. Okay, and this is on the right side show lens with anti-reflection coating. All right. Okay, next. Okay, the third application is in a noise cancellation. Okay, most people putting on a noise cancellation when they are jogging or when outside. All right, and it is also apply on board on an airplane. So microphone and transmitter system in a headphone used on aeroplane produce sound wave which interfere destructively with the surrounding noise. Okay, or as shown in this diagram. So it will produce silence. You won't hear sound produced from your surrounding. All right. Okay. Okay, so I guess that's all with the application of interference of wave in our daily life, and also we have solved a few example of question relate to interference, either for interference of light wave, water wave, and sound wave. So I hope you are for those who are following this lesson, understand interference in better way. And student, now I'm sharing to you the link for our ECET Sijil Express. So you can click on them, fill up your name and your IC number correctly, and then you may check the cert will be sending to your email inbox. So I guess that's all for tonight. Isanya itu saja untuk malam ini. Again, thank you very much for your time. Thank you very much for joining me. I really hope this lesson will benefit to those who are joining. You can also repeat this video again and again whenever you are free to get the full answer for the exercises I share to you in the video description below. So itu saja daripada saya, Cikgu Hasnitah. Alhamdulillah kita dah berjaya habiskan interference, dan jangan lupa bersama saya lagi pada minggu hadapan untuk tajuk yang terakhir for the last content standard in chapter 5, electromagnetic wave, dan minggu depan kita ada kelas untuk tingkatan 5 bersama dengan teacher Slinda Nordin pada hari Jumaat 9.30 malam. Ulang kaji skor A+ SPM, tajuk dia daya dan gerakan 2. So jangan lupa minggu depan kita ada 2 kelas fizik. Jumaat 9.30 malam ulang kaji SPM skor A+ bersama teacher Slinda Nordin, dan hari Ahad insya-Allah pukul 8.30 malam dengan saya, Cikgu Hasnitah, untuk tajuk seterusnya 5.65.7 electromagnetic wave. So itu saja pada saya. Segala yang baik itu daripada Allah, yang kurang itu daripada kelemahan dan kedangkalan ilmu saya. InsyaAllah semoga kita berjumpa lagi, dan salam kemerdekaan selamat Hari Kebangsaan ke-68 Malaysia Madani, rakyat disantuni. Assalamualaikum, selamat malam dan jumpa lagi.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini, lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.akademiyoutuber.com. Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Berusaha AYU, capai kecemerlangan, berpadu AYU, cipta kegemilangan, bersatu AYU, bina wadah terbilang, terus berjaya bersama AYU.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi Guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.